So, like RDD, data frame is also immutable, distributed collection of data. And unlike RDD, data is organized into named columns like RDBMS. This is what how a data frame looks like visually. If you have to see, there are rows and there are columns. Like if you were to visualize the RDBMS table, that's that will be a good analogy to visualize data frame also. You can read data from various sources. Just some of the examples. You can read Hive data, CSV data, JSON data, RDBMS data, XML data, Parquet data, Cassandra, RDD, ORC. There are many such things from S3, from Azure Blob Storage. So you could read from all of this and be able to create the data frame. And we'll see the examples. How you could even give the schema. If the schema, while creating the data, you will be able to provide the schema also. There are some examples below. So a data set is again similar thing, distributed collection of data. It got added in a Spark 1.6, and you can, this link I refer a lot. I want to see what all is available in Dataset. The difference between data frame and dataset is this. You can have a class. Let me cover the dataset, then I'll tell you the difference. Dataset provides the benefits of RDD for strong typing. This is one important thing which datasets gives. Ability to use powerful Lambda function, SQL optimization engine, and it can be constructed from JVM objects. So now what does this mean for strong typing and from JVM objects? I will have an example also, by the way, further for this, but let me try to explain verbally right now. Let's say you're trying to read a schema, and that schema is in a file, and that schema, you're trying to read a file, and that data in the file has certain schema, and that schema is, let's assume for our discussion, it has a column called ID, it has column called first name, last name, salary, date of birth, and city. These are the 5-6 columns you have in the in that schema for the data which is in the file. Now when you read that, sometimes you want to specify these columns. You could very well specify this column names as part of schema itself, which you can do in data frame. But beyond schema, let's say you have a class, and that class represents this. Let's say class name is customer or employee. Let's say class name is employee, and employee has the same columns. It has same variables, which are the columns in the schema. Employee the ID, first name, last name, date of birth, salary, and city. So employee class is representing the the schema which is there in the file. And what you want to do is you want to have a while you're reading that file, you want to have collection of the records in the in that object, employee object. So there will be many employee objects, each object of employee representing one record in that file. So if you want to have such representation of your data, that is when you use dataset. And here you can see one example. I have I'm trying to create a I have a class called person, which has name and age, and just for example purpose here, I have I have one record ND and 32, and I'm converting that to data set. So you will see the case class, this is a data set. So this is a data set of a type person, and I will show you more examples below. Now you can access the, if you have worked on Java list or Java array list or things like this, there are generics. You have list of type person, or you have list of type of some object. So something similar here, but this data set will automatically, so there are encoders, and we'll talk about those also. How does the data in the file get mapped to the one record in the file get mapped to one object of that class? So these are called encoders, and we'll discuss those encoders in detail. But this is what it means for strong typing. You can strong typing means the row in the file is one object, and then you have data set consisting of all such objects. So of course, you can manipulate similar as data frame. You can have map, flat map, filter, etc. It's available in Java and Scala. It's not available in Python and R. Why do you think it's not available in Python and R? If someone can guess the reason and either put it in the chat, I will read it out for that. Otherwise, we'll discuss towards the end. Data frames, as I discussed earlier, the data set organized into named columns, equivalent to RDBMS tables. This also we covered. It can be constructed from various sources. This is the one difference. This is one line which you have to remember. A data frame is data set of type dataset row. If you go and look at a Spark code, you will not find any class called data frame. You will find a class dataset only. But dataset of type row is again, if you do not know, it's again a Spark, construct. So dataset of type row is called data frame. Data frame is available in all languages, and this is how you present. The moment you see this in any Spark program, you can say that it's data frame. And now we'll take one example and we'll try to read some CSV file. And what I would recommend is that you go and write this program on your environment, whatever environment you have, so that you get some hands-on for this also. Anand Barn says Python and are not strong typecast. Very good. Java and Sahil says Java being compiled language is static typing. Absolutely. These are the answers. You already give the answers. So I am reading some file and this file is at this location. So if you are reading from S3, use prefix with S3. If you are reading from whatever HDFS, use suffix with HDFS. If you are reading from local file, possibly use suffix with F file : // But idea is that I'm reading this file. It's a CSV file. And here, see, Spark has this format. You will see this format quite often. Spark.read.format. And you pass CSV here. And I'll show you example when you read the JDBC also, data from the RDBMS as well. It's a similar syntax you will use. So it's easy to remember. Spark.read.format, CSV. And here I'm passing some schema. I have not mentioned the schema here, but in subsequent slide, I will show you how to create even the schema object also. So I'm passing some schema and I'm telling there's an option. So you can pass some options. One option is I'm telling header is true, which means that CSV file, first line in the CSV file is a header, so that it does not consider that line also, the header line also as part of the record. So it will skip that line. And you load, and this is of course the, this here I am not providing the schema. Here I'm providing the schema and telling header is equal to true and loading the file. So if I do not provide the schema here, then Spark will give some arbitrary column names. Let's say there are 3 columns into that file, so it will underscore C0 underscore C1 underscore C2. But if I provide the schema, whatever names I would give in the column names, I'll give in the schema. Spark will assign those column names to the record in that file. If I do not know the schema and I want Spark to infer the schema for me, so then I can pass it's the same thing. I am reading the CSV file from this location and everything else is same. Header is equal to 2. That first line is header, so it will skip that. It will not skip that. It will use the column names, the names of this header as the column names here. Here it will not use, but here given a header, it will use those column names as the in the schema in the data frame schema. Here now, what is the type? Whether some column represents a string, or it represents an integer, or it represents a boolean. What is that type? Or it represents a decimal. It represents a decimal. That I am telling Spark here to infer it itself. Then here, if I give this, then Spark is going to take a while to read this file, because it is going over all the records of this file and trying to figure out the data type of, only way it can figure out the data type is by going through all the records. So it will be a little slower, but here it will use the name of the column which are given in header. Here it will use the name of the column which are given in schema, and here it will give the arbitrary column names. So that's one example of reading the CSV files. Spark can read from data frame. Maybe I will add this in assignment also. I will give you if how do you read from a database? It's a JDBC call Spark will make, and I'll talk about a little bit of that. But if you want to practice, if you want to write a Spark program to read from a database and you do not have database set up on your local or anywhere, you can use this website, dbforfree.net. It gives you MySQL database free for certain time. So once you go there, it will, you are signing up, it will ask you this: what is your MySQL database name, user ID, password, and repeat the password and give your email address. So it will send all the information to this email address. And how do you use this information? You check, you'll get an email, you activate the link. So once you activate the link, it will ask you the admin. You can see on the UI itself. If you don't see, then click this link, copy paste this link in the URL. So it will show you the admin, MySQL admin. And on the UI, there will be a place to, create table. So create some table like, imply with, some ID and the name and age. And with this, type varchar integer. And what we'll do initially is, this table is blank, right? There's nothing in this table because we just created it. So we'll just read it and then save it. So this is how we want to do. So if you have Databricks, you can do on the Databricks. This is how you write. If you have local setup, do it in local. But if you're doing on local, you should be connected to internet because we'll be connecting to this host. So you can just say spark.read.format. Here we are using JDBC. Once you use JDBC, then it will expect certain options for this format. One, the URL where you're trying to connect to. So this is the host name. So this is the JDBC URL, JDBC MySQL, and the host name and the port. And this is a database name, demo Spark, which we had given here. This is the demo Spark dataset name. Then it's going to ask you which table, for which table we are trying to read. And then it will ask you the user ID password. So this is the table we have created here. And this is the user ID. And this is the password we have created here. So, so we are giving that. And it's reading. So right now, because we had just created this table, so it will not be, it will be empty. There will not be anything. So if you show it, you will see blank. It will not return anything. Now, what we are going to do is we are going to save something to this table. And that's coming in the next slide. So import this org Apache, Spark SQL types. What are these types? We are using this in the schema, and I'll talk about these types. First, randomly I'm creating, some record 1 ABC 20, 2 DF 30 and 3. So what are these? This is the employee ID. Remember this table we had created here. So it had the ID, name, and age. So this is what I'm creating to create 3 rows. First row with this ID, name is this, age is this. Second row with this ID, name and age. Then again ID, name, and age. 3 rows I'm creating, and this row is also a row is also part of this package. So I created these 3 records. Now here I'm creating. So I told you that you could create the schema at runtime. So when I showed you this, when you read from the CSV file, like here, when I was going to the CSV file, I was passing the schema here, right? But in this page, I did not specify how to create the schema. This is how you create the schema. If you want to create the schema, you create a struct type. And in the struct type, you add whatever, each column, what is the type, ID is string type, name is again string type, and age is integer type. So this is the, simpler way to create this. By the way, this is Scala syntax. Very similar is there in Python also. So now I'm creating a data frame. So this is the employee data. So I'm parallelizing it and I'm passing this schema. So I got this data frame. And I'm showing it to make sure that I know this is read properly, this data frame. Then I'm writing this data, writing this same thing, format JDBC. So now earlier it was df.read. Now I'm saying df.write. And I'm passing the format as JDBC and giving this URL, the table name, the user ID, and the password. The mode is save up append. So I think someone in the WhatsApp rightly said there are various save mode. There's a save mode append. There's a save mode overwrite, and things like this. So and you save it, and then you save it. So now you will see that, and if you run this program, once you do this, so you return it, right? If you want to read it back, you can run normal SQL, or you can run this program again because you are reading it from here, and you will see some records coming from that table. Now, one question is this. We discussed that when you are reading from HDFS, the block size of HDFS becomes one partition in the Spark, or one task in the Spark. Like block size, let's say 1 GB file with 256 block size, so there are 4 blocks. These are 4 partitions or 4 tasks in the Spark. But when you're reading from JDBC, how does Spark decide that these it needs to have these many partitions? Because partitions or tasks are the only way Spark can parallelize the data. If all data while reading from JDBC goes into one partition, then it's as good as writing a standalone Java program or Python program which is reading from the table. But whole idea we are using Spark is because we want to parallelize it. So how does Spark do the parallelization of JDBC? So Spark decide number of partition for JDBC using either of below options. First is, we said it, right? When you give JDBC option, we pass the URL, the table name, the column name. This is important. The column name, the lower bound and upper bound, and number of partitions. Whatever column name you are passing, this should be one of the column in the table, in this table which you're trying to read from. So this column should be of type numeric, date or timestamp. This column cannot be string or anything other than these one of these 3 types. The lower bound, you can give the the range endpoints. For example, if it is numeric, let's say I have 1 to 1 lakh records or 1 to 10 lakh records in the table. So I can give the lower bound as 1 and upper bound as 10 lakhs. And I can decide, then I can tell the number of partitions, how many partitions it should have. I can say 10, or based upon my hardware or whatever, I can say it's a 10 or 20. It just does not depend upon the hardware or which Spark runs. It depends upon the hardware which you have on your database also. Because as a big data developer who might not have good exposure to the RDBMS systems, we assume that whatever queries will fire on the on RDBMS systems, whether it is MySQL or SQL Server or Oracle or anything, that database will be able to take it. But in my experience, it doesn't work that way. Any query which hits the database servers, puts load on the server. So you can't just spin 10,000 queries to Spark and hit database with 10,000 queries. Your database will crash. So you have to work with the database team, the DBA database administrators, and figure out how many queries you will fire and how many, based upon that you decide number of partitions. So that's one way. The other way is that you can pass these parameters. So URL, of course, the JDBC URL, table name, and the predicates. The predicate is here array of where conditions for defining custom partitions. One advantage of using this is you can say where name is equal to name between this and this or whatever, or date date we have already covered here, or some other column value is equal greater than this and less than this or whatever. So you can specify all of that. This can be used for non-numeric columns also, and it can be used for dealing with skew. So skew is basically if you have let's say I'm talking about city names. City is my key, and the table has data for more number of records for Bangalore and Delhi, and very less number of records, let's say for I don't know, let's say Jaipur. So this becomes a skew. So if you're creating data, if you're partitioning or on the city names, then the partition for Jaipur will have very less number of records, whereas the partition for metro cities will have more number of records. So that becomes a skew. So to handle such scenarios, you can use this syntax to connect from JDBC. So this is your homework. Go and do this. There's one thing which you can try. So just go through this slides. You have link for all the, you will have the recording as well as the PPT also you have. Write this. If you don't have MySQL, then use this. One other thing which you can do is, if you are feeling little courageous, when you get data from when you read data, right? When you read data after loading it, read it again, you can apply some filter condition. Let's say, I don't know, I want to get records where age is greater than something. Now, why I'm telling you to apply filter condition is, there is one important thing, and we'll cover that in details also later, is this, there is something called predicate push down. Let's say your database has 10 million records, and those 10 million records, taking the city example again, those 10 million records belong to all the cities. Now let's say your processing is concerned with records only from Bangalore, Delhi, Chennai, and Kolkata. Only for, because you are doing some analysis for metro cities. You are not concerned about all other records from other cities. So what you can do is you can put that in filter condition, and you can say city, equal to, or whatever. You can city in or city equal, whatever you want to specify. You can put that as filter condition here. Now, one important thing is this. When you, so Dhruv has written correctly. So when you, put a filter condition, ideal situation would be that that filter condition gets evaluated at the database server only. Because out of, let's say, 10 million records for all the cities, your metro cities have only, the rows which are for metro cities are only 2 million. So you don't want to get all those 10 million records from database server to the Spark layer and then Spark filtering those out, because there's a huge network traffic involved. And of course, database, will also, it will be a hit on the database server also. So you would want database server to evaluate that condition, and out of 10 million, give only 2 million records, because those are for the metro cities. But how do you validate it? How do you know whether database is really doing this or not? Maybe database is sending you all 10 million, and Spark layer is doing the filtering, or database is really filtering at a database layer, which we want. So how do you validate that? So what you should do is, I will cover that in details also, but what you should do is type df.explain after reading it. Sorry, after you, or before read, you say, once you create, actually you can do it here only. Once you create all this data frame and then say JDBC df.explain. Once you explain it, there will be a, push down. You search for push down in that. If push down is equal to true, that means the database is doing what it is supposed to be doing. It's filtering those at the database server level only. If push down is false, then you have a problem. Then you have to figure out why the database is not filtering that. And I'll explain one example from my experience when it happened and how did we fix it. I will explain that. But having said it, I'll be covering this in much more details with examples in coming sessions. So we had this, if one of the things you should do is you should go and look at the documentation, Spark documentation. I tend to refer that very often. So if you go to Spark documentation, I will open that right here. So if you, so if you go to Spark documentation, you say Spark JDBC, it will show you the first page is documentation itself. So if you go here, so there is another option is Spark policy to write a query. So either you can give all of this DB table and all other things, or you can just give a SQL query like this person has given, select C1, C2 from table T1, correct? So this is another syntax you can give, URL and query. You don't have to give the things which have specified here, the URL, so the table and all those things, because this table is already part of your query itself. Now, once what we were doing was, we did not realize we were using this query option. And when we gave this query, we said select C1, C2 from table T1, and we said where, city equal to Bangalore, for example. Now, when we gave query like this, and we checked, we printed the plan. And again, I'm reiterating, how do you print the plan? You print the plan by putting DataFrame.explain. So you say df.explain, it will print the plan for you. So once you print JDBC df.explain, it print the plan. So in that, when we printed that plan, we realized that predicate pushdown is coming as false. And we're wondering why that is coming as false. And then later we realized that instead of giving the the where condition in this query itself, we could use the filter dot filter option of the data frame that triggered the that created the proper plan and enabled the predicate pushdown to happen on the database server itself. So these are some of the experience in the examples which I have come across from experiences, but it's always nice to not only while reading from JDBC, Anything you do when you're joining, I will cover the joins also later. When you're doing some heavy operations using data frame, it's always nice, in your dev or QA environment to print the plan and see it in a Spark is doing what you think it is doing in terms of optimization. And we'll have, some good number of slides covering that later. Does it give the execution plan for that query? Yes, and we'll cover the planning, Sahil later in detail. I have good number of examples for those. So this is about JDBC. Dataset, just reiterating it, it provides the benefit of RDD with the benefit of Spark SQL engine. It's the same thing. It came in 2016. So Dataframe is dataset of row and dataset is of type certain object. This is again, if you are just, here I have not given any schema. I have told that whatever is in the CSV file, I have some CSV file called data.txt. Whatever is that CSV file, just put that as one string. Then this is the way you do it. Say spark.read.text file, and it comes as a data set of string. And the column name is just value. So all the columns come under one value. I will show you further. If I want to have the proper schema also for this, I could do that. But if you want, in certain scenarios, I want all the records to come as, all the columns to come as just one, just one column in the data frame. So if you want, then this is the way. Some of the things, you can go and, read from here. Spark, there are two syntax, spark.read.text and spark.read.text file. Spark.read.text will return you data set of row and it have proper columns and everything. If you do spark.read.text file, it will return you data set of string. All the columns, full record as one column called value. You can go and read about this in detail. So I keep referring to, these APIs quite often. The difference between dataset, DataFrame, and RDD. So RDD, basically you should, as I said, you should try to avoid. And what we'll do, some of it we'll do today and some of it we'll do the next session is, we will go through some RDD functions, and RDD provide rich set of functions. If you have to use those functions, then go with RDD. And when I say you have to, because there's no other alternative, of those functions in dataset or data frame. So if that's the case, then use RDD, otherwise avoid. So it's all distributed for, processing. It uses MapReduce. It uses, dispute collection data into named column. We covered all of this, correct? Dataset will cover the encoders. How does dataset make sure that one record in the file maps to one object of a class? So that that is done through encoders, and we'll see example of that also later. All are immutable, all are fault tolerant, all are lazily evaluated, and all do the transformation action. Only thing is, you will get more optimizing. Spark optimizer work best on the data frame. There are small examples here. From when RDD is converted, you can convert an RDD to data frame, but then you cannot generate a RDD from the then RDD cannot be regenerated. So once you have the RDD to data frame and then you want to regenerate the RDD, that's not possible. Now it's in the data frame itself. So all have transformation action. We cover that. RDD doesn't have compile time safety. It has access of unknown columns in data frame. Does not show compile time error. If you want compile time safety, you use dataset. And someone replied, to some extent on this, that why Python doesn't have dataset. This is the reason. Someone replied it already. The access. So basically, what this is, what does this mean? Access to unknown column in data frame does not show compile time error. So when you're using a data frame, right? Data frame is nothing but data set of type row. And you might have some operation on that data frame. And on that operation, you might be referring some column which does not exist. And you will not get this error during compile time. If you do that, you will not get this error during compile time. If you use dataset during compile time while writing the code itself, you will see that error. This is type safe. Whatever I just explained is type safe. And when you get an error during the compile time, sort of consider as a type safe. If you get error during runtime, consider as untype safe. RDD is available in all these languages. Dataset is available in Scala and Java, not in Python and R. This cannot take advantage of Spark optimization, like Catalyst optimizer and Tungsten optimizer engine. It's RDDs don't interfere the schema. We need to use it. We have to specify this. You have to specify it here also, but here you have some option, like if you read CSV file, you can leave header equal to true. It will know that at least the column names or something like this. So this is what it is. I explained this. A syntax error you will get in Dataframe and Dataset in compile time. Analysis errors, if you use Dataset, you will get at compile time. If you use Dataframe, you will get it at runtime. I'll put these questions in the quiz, so you can refer this from the quiz. So I will not ask about I will not ask these questions now. There is one thing I always used to get confused between map and flat map. It's flat map, not flat map, sorry. I always used to get confused between map and flat map operations of Scala. This is very specific to Scala. It is not related to Spark or anything. So I just wanted to, I was thinking maybe there are more people like me who would be getting confused. So I wanted to write something to clearly distinguish what's the difference between map and flat map. So if you have a list, let's say 1, 2, 3, 4, 5, and you are doing, there's some function you have created. If element is greater than 2, then return sum of that element, else none. This is Scala syntax. And I use this map and pass this function in this map, right? I run a map over this. This is not a Spark map. This is just a plain Scala map outside Spark. So when I run this function for each element of the list, I like 1, 2, 3, 4, 5 are the elements of this list. For each element of the list, it goes to this function. So then what I get is I get list of none, because I have greater than 2. 1 and 2 are, it will return none. Then I get sum 3, 4, 5. But if I use flat map, it will just give me 3, 4, 5. It will remove none and sum and everything. It will give me 3, 4, 5. Now, how do you execute a program? I think someone asked me the ID thing. So Dhruv, thanks for putting that link. Someone asked the ID, how do you create a Spark program? So Scala shell is fine for debugging and everything, for testing, but ultimately you have to put your Spark program in a, you have to develop your Spark program in some IDE. So what I would recommend is, if you are using Scala, then download IntelliJ, Scala or Java, you download IntelliJ, and we'll maybe possibly in the next session, we'll set up your IntelliJ to run Spark session, and I will give you the setup instructions. Maybe I will share that in the assignment possibly if I can. So use those to set up your IntelliJ to create a Spark project and write some some lines of code there and be able to debug. So we'll see that possibly live in the next session. But you have some, let's say you have written a Spark program in Scala or in PySpark also, for that matter. Now you packaged it and it's a jar file for you. So I've created some jar file. Don't go by the name of this Spark Scala or something. This is the jar file of my application. This is just a path, but consider this is a jar file of my application. Then how do I submit my Spark job? The way I submit Spark job is I use a Spark submit. By the way, let me go through all of this. If you're creating a Spark package if you're writing the Spark code in Scala, then you will be using, most likely you'll be using SBT. And SBT comes, it's a build tool, Scala build tool. Because you're writing in Scala, so you can, once you have written your code, and you can compile in and package that code using this command, SBT clean package. Once you do SB clean package, it will create a jar file for you. Once it creates a jar file for you, this will be your jar file. There's some name, whatever name of your project is, based on that will create a jar file. In your code, what you got compiled and packaged in your code, you will have some main method, right? Because if you have ever worked on Java or Scala, the entry point is always main method, and it's same in many programming languages also, like so main method is well known if you are a developer. So you have to give your class, when in Spark submit -FN class, and you have to give your main class method. sorry, main class name, not method, main class name, that will be basically, this is your driver class name, honestly. So you, once you package it, you say Spark submit, then say, tell Spark that this is my main class, which is nothing but your driver class, and this class and other related application code exist in this jar. And then, what I try to do is I have tried to put some, data into this directory, and then forget about this line and this line. I was trying to do something and I did not complete that. So forget about these two lines, focus on this and this. So once you do Spark submit, if your bin Spark bin folder in your class path, if you're doing it on local or on server, if it's in class path, then you can just say Spark submit, or you go to that, folder where that, Spark base folder and type this command, Spark submit, give the main class, give the master. I think we discussed the master earlier, whether it is yarn or, local or something. So we have discussed that. We have discussed a deploy mode. On yarn, you can run in client mode or cluster mode. You could give that. You can pass a Spark configuration. This is very important. Spark provides you a hell lot of configurations. And there is one page from the Spark documentation, which has all the configuration defined. We'll cover some of the important configurations in coming session. I can give you some example. One configuration is, driver memory, the number of executors, executor memory, executor cores. So things like this you could give in the configuration. And based upon that, Spark will spin up the, the executors and tasks inside those executors. And of course, you have to give your application jar, which you are giving this. Additionally, if your main method is accepting some parameters, the command line parameters, so then you could give those also here. So this is the Spark submit job. This is a Spark submit command. I will take 5 more minutes to cover this. Then I will stop and go to the questions. One important thing to realize is that each action is a job. So we discussed about, Spark transformation and action. So each action is a job. If you go to the Spark UI, and I have an example of that also later. If you go to the Spark UI, you will see that you submitted one job. You submitted one application through Spark submit, but you will see 2 jobs there on the UI. Those 2 jobs are there because you have 2 actions in your application. One might be collect, second might be save, or one might be saving to a file, second might be saving to a database. For that matter, whatever action you have, these are just example of actions. So whatever actions you will have, those will appear as one job on the Spark. So this is the in layman terms. If you go to the Spark documentation, what Spark documentation say about job is, a job is a parallel computation consisting of multiple tasks that gets spawned in response to a Spark action, save, collect. You will see this term used in driver logs. So basically what it is saying in reality is that if you have any action, then that action is a job, and that job will trigger multiple tasks. Those tasks will run inside the executor and everything. It did not say that, but that's what it will happen. So it will spin up the task which will run inside the executors. We'll go through this example, and then we'll go to the question answer session. Let's say you load a file with people names and addresses into RDD1. So I have given RDD example, but similar thing will for Dataframe also. Load another file with people names and fonts in RDD2. So it has name and address, it has name and fonts in RDD2. I'm joining RDD1 and RDD2 by name to get RDD3. So these name is common. So I'm joining it to get RDD3. Now I'm mapping the RDD3 to split phone number into area code, phone number for each person as RDD4. So over this join data set, I'm applying some map operation. Right? Forget this splitting and all this. Assume some map operation is being applied. The RDD4, I'm saving it to a file. Now what I do is I have this RDD1 still with me. So I apply a map operation over this RDD1 to extract zip code from the addresses to get RDD5. So in RDD5, we'll have the zip codes which are extracted from RDD1. Now I will aggregate on RDD5 to count of how many people live in each zip code. I'll get as RDD6. I will collect on RDD6 and print this stats to std out. So you don't have to understand the logic of this. Only thing you need to worry about is I'm loading a file, joining, mapping, and then saving, and then mapping, and then aggregating and collecting. So all of these steps will be part of, you'll be writing in your driver program. A step 5 here, because you're saving to a file, it's a job. And in step 8, you're collecting is, so why step 5 is a job? Because it's an action. Step 8 is also a job because it's another action. There are only 2 actions here, 5 and 8. So these are actions and no transformation. What are others? You are loading it, you are joining it, mapping it. These are all transformations. A job is sequence of one or more stages. And what are those stages? We'll talk about that later. What are stages? We'll talk about that later. A task is a particular piece of data that will go through a given stage on a given executor. If you remember the first diagram which I showed you, that an executor can have one or more tasks. So in reality, that's what it is saying. Now, what is a stage? I will cover in detail later, but I will give you one example, a high-level overview of what stage is. When you're loading a file, so here we joined, for example, right? I'm loaded, one file here, second file here. I did a join. When you are joining 2 big data sets, first data set has data stored on n number of nodes. Second data set has data stored on x number of nodes. When you're joining, the movement of data from these nodes will happen so that data from the same join key can come to the same node. Let's say I'm joining based upon people name. Then for RDD1, the some person's name in on node 1 and node 2. For RDD2, same person name is on node 5 and node 6. But when joining, for the join data set, data from node 1 and node 2 for RDD1 and node 5 and node 6 from RDD2 should come to one common node. So that's called shuffle. So data is moving from one node to other set of nodes. So the moment that shuffle happens, that means a new stage is getting created. One shuffle means one extra stage. So that's what stage means. So at the minimum, you will have one stage in your any Spark program if there's no shuffling at all involved. So you'll have at least one stage, and the tasks are running inside the stage. There are executors running inside the stage, and tasks are running inside that executor. That's what this line is trying to say. Let me see what else is left. This I explained. We'll cover shuffle in details later. Then we'll cover the RDD and some common functions on RDD and everything. So I'll stop it here, and let's move on to the question answer session.